Have you ever wondered how artificial intelligence is reshaping the world around us? From smart assistants that manage our daily tasks to algorithms that predict weather patterns, AI's touch is everywhere. It's not just about technology, it's about how these advancements are integrated into every facet of our lives. Understanding AI's core domains and their applications is crucial as they drive innovations across industries. Today, we'll uncover some of these transformative domains and applications of AI. So, what exactly are the domains of AI? When we talk about artificial intelligence, it's not just a singular monolithic field, it's a vibrant landscape, comprising various specialized domains, each with its unique focus and applications. Let's delve into some of the major domains of AI that are shaping our world. First up, we have machine learning. This is perhaps the most well-known domain of AI. Machine learning algorithms use statistical methods to enable machines to improve at tasks with experience. For example, recommendation systems on streaming services like Netflix or Spotify use machine learning to predict what you might want to watch or listen to next, based on your past behavior. Next, let's talk about robotics. This domain involves the design and creation of robots that can perform tasks usually requiring human intelligence. These tasks can range from assembling cars on a production line to performing complex surgeries. Robotics combines elements of AI, engineering, and computer science to create these capable machines. Another critical domain is natural language processing, or NLP for short. NLP helps computers understand, interpret, and generate human language. Whether it's chatbots assisting you on websites or voice-activated assistants like Siri or Alexa responding to your queries, NLP is the technology making these interactions possible. Each domain of AI not only pushes the boundaries of what machines can do, but also complements the others, contributing to the overall intelligence of systems. Thus, each domain represents a specialized branch of AI, working together to create intelligent systems. Data acts as the fuel for AI, but how? Imagine trying to teach a child to recognize different fruits without ever showing them an apple or a banana. It sounds impossible, right? Similarly, artificial intelligence systems require data to learn and make sense of the world. This data can come in many forms, and its complexity and structure can vastly differ. In the realm of AI, data is typically categorized into two types: structured and unstructured. Structured data is highly organized and easily searchable, often stored in databases with defined categories like age, price, or date. This type of data is straightforward for AI to process because it follows a specific format. On the other hand, unstructured data includes text, images, and videos. It's messier and more complex, requiring more sophisticated methods for processing and interpretation. AI uses advanced algorithms to find patterns and learn from this type of data, which makes up the majority of data available in the digital universe. Without data, AI systems cannot learn or make decisions. Imagine a machine that can see and understand its surroundings. That's the essence of computer vision, a fascinating domain of artificial intelligence. It empowers machines to process and interpret visual data, much like humans do with their eyes. Computer vision uses algorithms that can identify patterns and features in images and videos. This capability is transformative across various industries. For instance, in security systems, it allows for sophisticated facial recognition that can distinguish individuals among crowds, enhancing both safety and surveillance capabilities. In the realm of transportation, computer vision is the cornerstone of autonomous vehicles. It enables cars to perceive road conditions, detect obstacles, and make informed decisions, paving the way for safer and more efficient travel. The medical field also reaps benefits from computer vision. It aids in the analysis of complex medical images, such as X-rays and MRIs, helping doctors diagnose diseases with greater accuracy and speed. Through these applications and more, computer vision enables machines to interpret and interact with the visual world. How is AI making waves in water management? Artificial intelligence is diving deep into the realm of water resource management, offering innovative solutions that were once considered futuristic. By utilizing advanced prediction models, AI can forecast water demand with remarkable accuracy, helping cities and communities plan more effectively. Moreover, AI-powered quality monitoring systems are constantly analyzing water quality in real time, detecting impurities and contaminants long before they become a health issue. This proactive approach not only preserves our most vital resource, but also exemplifies how AI helps in sustainable management of water resources, ensuring efficiency and conservation. Self-driving cars are no longer just science fiction. Artificial intelligence is the powerhouse behind the wheels, steering the future of transportation. Imagine a car that perceives its environment, makes intelligent decisions, and navigates roads with precision, all without human intervention. This is the reality of autonomous vehicles today. At the heart of these vehicles are sophisticated AI algorithms. These algorithms process vast amounts of data from various sensors, cameras, radar, and LiDAR, to create a detailed map of the car's surroundings. This sensory information is then analyzed to detect obstacles, predict the actions of other road users, and make real-time driving decisions. However, the road to perfect autonomy is fraught with challenges. AI systems must be trained on diverse datasets to handle all possible scenarios they might encounter on the road. Weather conditions, unpredictable human behavior, and varying traffic laws across regions pose significant hurdles. Despite these challenges, advancements in AI technology continue to drive forward the capabilities of self-driving cars. AI is key to the development of safe and efficient autonomous vehicles. In AI, what do we mean by station? Well, the term station isn't as commonly heard as neural network or algorithm, but it's equally significant. When we talk about stations in the context of AI, we are usually referring to either data stations or network nodes. These are critical points where data is collected, processed, or transmitted. They serve as the backbone of AI systems, ensuring that data flows smoothly from one point to another, facilitating seamless communication across different AI processes. Understanding these stations helps in comprehending the AI network and data flow. How do machines understand human language? This question is at the core of natural language processing, or NLP, a fascinating domain of artificial intelligence that deals with the interaction between computers and humans using natural language. The goal of NLP is to read, decipher, understand, and make sense of human languages in a manner that is valuable. It involves everything from analyzing large amounts of text to understanding the intent behind spoken words. This technology powers some of the most innovative tools we use today. Take, for example, translation services. NLP algorithms help translate languages in real time, breaking down barriers in global communication. Then there are virtual assistants like those on our phones and in our homes, which rely on NLP to respond to our queries and commands effectively. And let's not overlook sentiment analysis. Businesses use NLP to gauge public sentiment from social media data, helping them tailor their strategies and products. NLP bridges the gap between human communication and machine understanding. Ever wondered how your email stays free of spam, or your photos get automatically enhanced? In the vast digital landscape, artificial intelligence plays a pivotal role in filtering out the unnecessary and enhancing the necessary. Let's dive into the world of image and spam filters, both of which are powered by sophisticated AI technologies. Image filters are not just about adding a vintage look or a sepia tone to your photographs. AI-driven image filters analyze the content of photos, adjusting brightness, contrast, and even suggesting the best crop. They work by learning from vast data sets of images, understanding what improvements can make a photo more pleasing to the eye. On the flip side, spam filters are the unsung heroes of our email inboxes. They use AI to scrutinize incoming messages, determining which are legitimate and which are junk. By learning from patterns in billions of emails, they block potentially harmful messages and phishing attempts, keeping our digital communications smooth and safe. AI filters are essential for improving digital experiences and security. As we've seen today, AI's reach is vast and varied. From the intricate domains of artificial intelligence, including computer vision and natural language processing, to its practical applications in self-driving cars and water management, AI is reshaping the way we interact with the world. We've explored how data serves as the backbone of AI, fueling algorithms with the information needed to make intelligent decisions. In domains like computer vision, this data helps machines to perceive and understand the visual world at a level often surpassing human capabilities. Meanwhile, natural language processing allows for more intuitive interaction between humans and machines, transforming vast amounts of text data into meaningful conversations. AI's role in self-driving automobiles highlights its potential to enhance safety and efficiency in transportation. Similarly, its application in managing water resources underscores its capability to address critical environmental challenges. The future of AI promises even greater innovations and challenges. The journey of understanding and adapting AI continues.